When looking at the ocean water, we often talk about the parts of a wave. And while it's not super complex, the concept of wave base can be a little confusing. So I'm going to talk a little bit about the parts of the wave and then talk about how you figure out where the wave base is. All right, so here's my waveform where say it goes left to right across. And what we learned is that if you take a particle of water, it's actually going to make a circular motion like this. And we call that an orbital. And when it's at the very top of its orbit, it forms the crest of the wave. So this high point is called the crest. And then as the particle travels down and hits the bottom of that orbital, like right here, that forms the low part of the wave. So we call that the trough. All right, and so when we look at measuring the wave, we often think about wave height and wavelength. So let's look at that. Our wave height is just going to be the vertical distance between crest and trough. So I would say my crests are all cresting out about here. If I look across there, my troughs are all kind of right in here. So let me draw that there. And so this would be my wave height, just the distance between the crest and the trough. So wave height. That's a vertical measurement. My wavelength is going to be a horizontal measurement, and you can really pick any two similar points on consecutive waves. And what that means is you can go crest to crest, trough to trough, midpoint to midpoint. It's like back spots here, midpoint to midpoint here. It doesn't really matter as long as it's consecutive. You couldn't go, trough to trough, 2 waves apart. That wouldn't make any sense. So in this case, let's just go from crest to crest. So I would go from here to here. That distance here would be my wave length. And we often use the lambda symbol for that. So you might be seeing that. All right, so those are the basics. What we also know is that these orbitals actually continue downward. So if we take this little spot of water, they get smaller as you go down. They get smaller and smaller so they disappear. And we often want to know, when does that motion disappear? Because it's just moving water. So how far do we have to go down to have a still, quiet ocean water experience? And what that is, it's called the wave base. It's the base that marks the bottom of the wave motion, and below that it's still. And so when we look at how deep the wave base is, what we want to do is we want to do half the wavelength. So wave base equals half of the wavelength. So how do we measure that? And what we would do is we'd say, okay, our wavelength is this much, we'd half that. So here is half the wavelength, that distance there. And I would take that and I would take the center line of my wave. So if the water was still, where would that be? So I'm going to take that and then come down and measure off of that center line. And you can see if I do that, it sets me right in here. So my wave base, and I lucked out, I drew that in the exact right spot, is right here. So wave base, that's it. It's half of the wavelength taken from the midpoint of the waveform down. So hopefully that helps as well.